Dear students, welcome to the lecture series on the topic engineering graphics. So today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. A straight line, it is the shortest distance between any 2 points in the space. Another definition of the line is, that is, the line represents the locus of a point moving along a fixed path in the space. As the line consists of number of points, its projections are drawn by joining the projections of any 2 points on the line, and usually these 2 points will be the starting point and end point, that is the end points of the line over there. Now whenever we say that we want to draw the projections of the line, it means that we want to draw the front view, top view or the side view of the line. And in order to draw the projections of the line, we need to acquire the information about the coordinate locations of the line into the space. So the first thing which will be required will be its true length. We need to know the actual length of the line. Then the second is, we need to know about the position of its ends with respect to the horizontal plane and the vertical plane. And besides this, another information required is the inclination of the line with the reference planes, that is horizontal plane and the vertical plane. Now here we are going to discuss about the projections of the lines which is at different locations in the space with respect to the reference planes, horizontal plane and the vertical plane. So these are the 8 cases we are going to discuss one by one. So the first case is the line parallel to both the reference planes. Second one, the line is perpendicular to the horizontal plane and parallel to the vertical plane. The third case is regarding line perpendicular to the vertical plane and parallel to the horizontal plane. Then next one is the line inclined to horizontal plane and parallel to the vertical plane. Next, the line inclined to the vertical plane and parallel to the horizontal plane. Then the sixth case is line parallel to or contained by the profile plane. Then the seventh one, line contained by both the horizontal plane and the vertical plane. And finally, it is the line which is inclined to both horizontal plane and the vertical plane, and this type of line is called an oblique line. Now you can see in the first 7 cases we have highlighted the word parallel or contained by, because if a line is contained by HP and VP, it means it is parallel to HP and VP. So the crux of the situation is that in the first 7 cases the line happens to be parallel to either both the reference planes or either the horizontal plane or the vertical plane. Now if a line happens to be parallel to both the reference planes or one of the reference planes, its projection on that particular reference plane will provide its true length. So here you can see, here we have got a line which is there in space, and this line is parallel to both vertical plane as well as the horizontal plane. And since the line happens to be parallel to both of these planes, so we can get the true length of the line. The projection of the line will be true length in the front view as well as in the top view. So similarly, if the line happens to be parallel to any one of the reference planes, then the projections of the line have to be drawn on that particular reference plane to begin with, because it is going to reveal the true length or true shape of the line on that particular reference plane. Then the second situation is that there will be certain conditions where the line in orientation will be inclined to a particular reference plane. So here you can see in case number 4 the line is inclined to HP, and in case number 5 the line is inclined to VP. Now whenever the line is inclined to any given reference plane, so here you can see we have taken one example over here, that whenever a line happens to be inclined to any given reference plane, so here in this case we have assumed that the line is inclined to the horizontal plane. So its projection on that particular reference plane will reveal its apparent length or the reduced length. We call that there will be foreshortening of the true length of the line. So whenever we look at a line when it is inclined with respect to a particular reference plane, its projection on that reference plane will reveal its shortened length, and this shortened length is called apparent length of the line. Then when this angle of inclination increases, obviously this reduction is going to get higher and higher. If this angle is lesser, the reduction will be lesser, that is apparent length will be closer to the true length. If this angle of inclination keeps on increasing, the foreshortening of this length will be higher and higher. And what happens if this angle becomes 90 degree? That is, the line becomes perpendicular to that particular reference plane. So if the line becomes perpendicular to any one of the reference planes, then you can see that in this case the line happens to be perpendicular to the horizontal plane. So if a line happens to be perpendicular to a reference plane, then its projection on that reference plane will become a point over there. That is, the length of the apparent length of the line will become 0. So line gets converted into a point. So this view we call as point view of the line. So these three things we need to remember. Whenever a line is parallel to a plane, the projection on the plane will reveal its true length. Whenever the line is inclined to a plane, the projection on that plane will reveal its shortened length. Whenever a line is perpendicular to a reference plane, its projection on that plane will reveal its point view. So these 7 cases, first 7 we are going to discuss in today's lecture, whereas there is another line which is inclined to both HP and VP. If the line is inclined to both HP and VP, so we are not going to get the true length of the line projections either on HP or on VP, since the line is inclined to both the reference planes. So there we cannot determine the projection straight away. So then separate method has to be used over there. So this we are going to pick up in the next lecture. So before we start with all these first 7 cases, let us start with the terminology which will be used in the projection of line. So the first term which we are going to use in the projection of line, this we have already talked about, is the true length of the line. So the true length of the line is the actual length of the line. So whatever is the length of the line, that is called the true length. And when the true length of the line will be visible on horizontal plane or the vertical plane as projections, when the line happens to be parallel to either horizontal plane or vertical plane. So we need to remember that the true length of the line will be obtained on any given reference plane, that is HP or VP, when the line happens to be parallel to either HP or VP or both of them. Then the second term which we are going to use during projection of lines discussion will be apparent length. So we have already discussed that whenever a line is inclined to any given reference plane, its projection on that particular reference plane will reveal its shortened length. So this length is called the apparent length of a line. And also another thing we need to remember, apparent length of a line is always shorter than the true length of a line. And how much reduction will be there? Obviously we have discussed that the reduction will depend upon extent of inclination of the line with respect to a given reference plane. Lesser the angle of inclination, lesser will be the reduction in the apparent length compared to the true length. More the reduction will be there when the angle of inclination happens to be more. Then the another definition is plan length or top view length. Whenever we are looking at any particular line which is situated in space from the top, whenever we are looking at the line which is situated in the space from the top, the projections of the line as seen in the top view, and this top view will be drawn on always on the horizontal plane. So this is called plan of the line or top view of the line. That is, whenever we are looking at the line from the top, the projections which are obtained on the horizontal plane, they will be called top view projections or plan projections. Similarly, the elevation length or front view length, so this is the length or the projection which is obtained on the vertical plane when we look at the object from the front side. So whenever we are looking at the line from the front side, the view obtained on the vertical plane will be called the elevation length. Now this is represented by small a dash and small b dash. So if we are not going to tell you that whether a dash b dash is elevation or plan, so this thing should be understood to you. A dash and b dash, they are the representations or notations of the front view. Small a and small b, they are the representations of the top view. Then the next definition is side view length. So whenever we look at the object from the side, it can be from the left hand side or from the right hand side, the projections of the line as seen on the profile plane in the side view, they will be called side view length. And there can be two types of side view lengths. One can be left side view and another one can be right side view. Then the next definition is point view of the line. So this also we have discussed. Whenever the line happens to be perpendicular to any given reference plane, its projection on that particular reference plane will become a point, and both the views of the two ends, they are going to coincide over here, leading to generation of a point view. So the view obtained on that particular reference plane will be called the point view of the line. Then the next is the inclination of true length of the line with respect to horizontal plane. It is called theta. So whenever a line is inclined, that is whenever the true length of the line is inclined with respect to horizontal plane at any given angle, that angle is given the name theta. Similarly, the inclination of true length of the line with the vertical plane, it is called phi. So whenever you have a true length of a line, or whenever we say that a line is inclined to VP at an angle of 30 degree or 45 degree, so this angle we are going to designate as phi. Then another two terms we are going to add over here, that is traces of the line. So the trace of the line means that it is the intersection of the line with a particular reference plane. So the line may itself intersect with a reference plane, or if it is not intersecting directly, it has to be extended to make it meet the given reference plane. So when this will happen, when the line happens to be perpendicular or inclined to a particular reference plane. Because whenever a line is parallel to a reference plane, it is not going to intersect with that particular reference plane. So since you have two reference planes over here, so the first type of trace is called the horizontal trace. So what is the definition of the horizontal trace? The horizontal trace, it is the point of intersection of the line itself or its extension with the horizontal plane, because the name is horizontal trace. So the intersection of the line with the horizontal plane is to be checked out. So it is the point of intersection of the line itself or its extension with the horizontal plane. So this is called the horizontal trace of the line, and it is measured as the perpendicular distance of this point of intersection from the XY reference line. So here you can see, here we have an example over here where the line used to be happened to be perpendicular to the horizontal plane. Similarly, the line could have been inclined to the horizontal planes, it would have intersected with the horizontal plane. So in this case, you can see, since the line happens to be perpendicular to the horizontal plane, it is not directly intersecting with the horizontal plane. So what we have to do, check, we have to extend this line till it meets my horizontal plane. So this point of intersection will be called H, because it is appearing in the plan or the top view of the projection. Now how it is measured? It is measured as this distance of this point of intersection from the XY reference line. So this distance we have to measure, and this will give us the horizontal trace of the line. Similarly, the next type of the trace is called vertical trace. Now the vertical trace, it is the point of intersection of the line itself or its extension with the vertical plane. So here you can see, here we had a line which was perpendicular to the vertical plane. So since this line is perpendicular to the vertical plane, it is going to intersect with the vertical plane. But does this line itself intersect with the vertical plane? No. So what we have to do, we have to extend this line till it meets at a point with the vertical plane. Now once we extend this line, you see the point wherever it intersects, we call it V dash. Why we call it V dash? Because it is appearing on the vertical plane, and on the vertical plane the elevation or the front view points will be described. And now how the vertical trace will be measured? Now once we have obtained this point of intersection, now we have to take the perpendicular distance of this point of intersection from the reference line, which is our XY line. So this distance we are going to call as vertical trace. So this is the basic definition of horizontal trace and vertical trace. Now the illustration for the another example when the line will not have a trace. So here you can see in this case the line happens to be parallel to both VP and HP, and since this line happens to be parallel to both HP and VP, this line will not have any trace. Similarly, in the previous two cases I did not tell you deliberately that this line happened to be parallel to the vertical plane in the first case. So since this line happened to be parallel to the vertical plane, so two parallel things, they do not intersect. So this line CD is not going to intersect with the vertical plane. So we will conclude over here that this line will have only the horizontal trace but no vertical trace. Similarly, vice versa, this line is perpendicular to the vertical plane, so that is why it was having the vertical trace. But this line is parallel to the horizontal plane, so no way it is going to intersect with the horizontal plane. So this line will not have the horizontal trace over here. So first two situations you have only one trace, whereas in the last situation you do not have any one of the traces, that is HT or VT, because the line happens to be parallel to both the horizontal plane as well as the vertical plane. Now let us start with the 7 cases of the projections of lines that we have discussed. So the first case is projections of the line which is parallel to both horizontal plane and the vertical plane, that is line parallel to both the reference plane. So let us read out the statement. The statement reads as there is a line 40 mm long which is parallel to both HP and VP, and since this line is parallel to both, we need to know about its distances from HP and VP so that we can locate this point spatially into the coordinate planes from the HP and VP. So here you see we have drawn HP and VP, that is horizontal plane is this, vertical plane is this. Now this is my line. I have located my line over here. How did I locate my line? I have located my line in such a way that its distance from HP, you see I have been provided with this coordinate location. Distance from HP happens to be 25 millimeter and the distance from VP happens to be 30 millimeter. So just see the line length is 40 millimeter as it is given over here. This is the true length of the line. Now I am going to mark the distances of this line from HP and VP. So just see, distance of the line from HP I have marked as 25 millimeter. Distance of the line from the vertical plane I have marked as 30 millimeter. So after marking these two distances, that is distance from HP and distance from VP, I will be able to draw this line. So having been able to successfully locate this line into the space which is governed by HP and VP, I work out that this line is located in the quadrant number 1 because this lies above HP and this line lies 30 mm in front of VP. Now I need to draw the projections of this line. So the line is located over here. You see now the observer is going to look from the front. I want to draw the front view first, but you could have drawn the top view also. Why? Because this line happens to be parallel to both VP and HP. I told you earlier, you have to draw those projections first corresponding to the location of the line. If a line is parallel to a given reference plane, you have to draw those projections first. So since this line happens to be parallel to both the reference planes, so it is your choice whether you want to draw the front view or you want to draw the top view. So I want to draw the front view first. So the one thing you need to remember over here is that the front view will always be drawn on the vertical plane and it will be represented by small a dash and small b dash. So I am looking from the front. As the observer is looking from the front, the projections from points A and B, they will converge onto my vertical plane and they will meet the vertical plane. These projector lines, they will meet the vertical planes at these 2 points. And what are the names of these points? Point A will converge at A dash, point B will converge at small b dash. So since this line happened to be parallel to the vertical plane, so whatever front view we have obtained, that is a dash, b dash, this front view will reveal the true length of a line. So I am not going to show it again because I have already shown it 40 mm over here. So no redundancy should be there, no repetition of the marking of the dimension should be there onto the drawing. Similarly, now I want to look at this particular line from the top. As I am looking at this particular line, or the observer is looking at this line from the top, now the projections which will be obtained, these projections will be obtained on the horizontal plane. As I am looking from the top, the name of these projections will be top view projection. So please check, A and B, the projector lines, they will be converging on horizontal plane at small a and small b points over here. So just see, I put down these arrows, and this is the coordinate location of the top view of the line as it appears to an observer which is looking at this line from the top. So this is, once again, since this line happens to be parallel to HP, the top view which has been obtained, that is AB, will reveal the true length of a line. Now you can see that I have obtained the front view, which is the true length. I have obtained the top view of the line, which is again the true length, but both of these projections, they are obtained in mutually perpendicular reference planes. So I want to draw it onto my drawing sheet, which is a 2D sheet, which is a single plane. So I have to rotate this horizontal plane clockwise downward. So these are, you see, the projector lines which I have drawn to show you the interrelationship between projections of A dash and A, that is, they will be falling in one line, one vertical line. Similarly, the projections of B, they will also be falling in one vertical line. So this way, now I need to rotate my horizontal plane clockwise downwards. And another thing, since this line happened to be parallel to both HP and VP, so this line will not be meeting either HP or VP. So it will not have any trace. No horizontal trace will be there, no vertical trace will be there. Now let us draw the projections as you have to do it onto the drawing sheet. This is only for 3D spatial understanding, not to be drawn on the drawing sheet, but this is what you have to draw. So in the front you have the top view, at the bottom of the XY line you have the horizontal plane. So first of all, you see the distance of this line, front view, from the XY line is 25 millimeter. So I'll draw 25 millimeter 2H line. This is my dimension line. These are my construction lines or the projection lines. Now I need to draw this length 40 millimeter because the projection A dash B dash happens to be 40 millimeter, which is situated 25 millimeter above the XY line, reference line. Similarly, when I want to draw the top view, you see this top view is 30 millimeter from the in front of the vertical plane. So anything which is in front of the vertical plane, you rotate it downwards, it will appear below the XY line. So this is my 40 millimeter. Now front view, which is the true length. Now I want to draw the top view. Top view is 30 millimeter below the XY line. It is this distance, 30 millimeter. So this distance will also be 30 millimeter. So now I draw the H with the help of HB line because it is an object line, and mark points A and B. This is point A, this is point B. So once I have marked this 40 millimeter, I don't need to mark this 40 millimeter again because dimensions redundancy should be avoided. And this is my top view, which is again the true length. So this is the complete description about the line which happens to be parallel to both the reference planes. So you are going to obtain true length of the line in the front view and true length of the line in the top view. So this position, that is distance above HP, will appear here. Distance in front of VP will be appearing below the XY line. Now the second case, now we are going to pick up a line CD which is perpendicular to horizontal plane and parallel to the vertical plane. So this line happens to be perpendicular to HP and parallel to VP. Now let us read out the statement. Line CD is 50 mm long, which is perpendicular to HP. Automatically this will become parallel to VP. Its end C is 15 mm above HP and 25 mm in front of VP. That is, you see, this line happens to be 25 mm in front of VP. So I'll have to mark this distance as 25 mm. And the first end of the line, it happens to be 15 mm above HP. That is, my line will start from here. So I have to leave 15 millimeter from the horizontal plane, draw the line, but I cannot draw it here because I have to mark this line 25 millimeter in front of the vertical plane. So let us see how we can locate this point spatially into the coordinate system. So HP, VP and then XY line we have drawn. So you see, this is the line which we have marked over here. 50 mm is the length of the line. Now I have to show that this line is 15 millimeter above the horizontal plane and this line will be 25 millimeter in front of the vertical plane. So just see, I'm going to do the marking. So this line happens to be 25 millimeter away from the vertical plane and this line happens to be 15 millimeter above the horizontal plane. And once I locate these two coordinates, then I can mark the position of this particular line. So here you can see this is the true length of the line, that is 50 millimeter. So I mark this 50 millimeter. Now since this line happens to be parallel to VP, now I don't have any choice. Line is not parallel to HP, line is parallel to only VP. So the first projections which I will be drawing, I am forced to draw the first projection on the vertical plane. Why? Because the line is parallel to the vertical plane. So here you go. I have drawn the front view notation over here. Observer is going to look at this line from the front. So point C will get projected over here. Point D will get projected over here. Now please check. Point D will get projected over here. Point C is getting projected over here. So the name of this point will be small c dash because it is the front view. Name of this point will be small d dash because again it is front view which is obtained on the vertical plane. Now let's join these two points and do the naming. So C dash is the front view of the point C, D dash represents the front view of the point D. And since this line CD happened to be parallel to VP, this projection of this line, true length of the line CD, which appears as C dash D dash onto the vertical plane, will show me the true length of the line. So this is again 50 millimeter. If I have shown 50 here, no need to show 50 on the other side. Now I want to draw the top view of the line. I am looking from the top, that is observer is looking at this line from the top, and this we already know by now that whenever a line happens to be perpendicular to a reference plane, both the projections of its two ends, they are going to coincide and I am going to obtain the point view of the line onto that particular plane. So in this case my line was perpendicular to the horizontal plane, so my projections of point D and point C, they are going to converge and I am going to get D comma C because top view has to be represented by small alphabets without a dash. So D and C represent the projections of my line CD as it appears on the horizontal plane in the top view. So I can say that my top view represents the point view of the line, right? So this is my point view of the line. So projections I have obtained. Front view projection will be C dash D dash 50 mm, which will be 15 mm above. You can see I have marked this line 15 mm above the horizontal plane, and my top view will be point D and C, which will be 25 mm away from the vertical plane. So I need to rotate this so I can draw the projections, but before that I want to work out the traces of the line. Since this line happens to be perpendicular to HP, so it is going to intersect HP either itself or through its extension. So does this line intersect HP directly? No. Then I need to extend this. The moment I extend this, you can see again it is going to meet my horizontal plane at this particular point. That is the point of convergence of D and C. So I'll mark this point as H. So this is going to give me the horizontal trace. So this is the point of intersection of the line itself or extension with the horizontal plane. So we call it H. Why we did not put any dash? Because it is obtained on the horizontal plane. So all points which are obtained on horizontal plane will be represented by small alphabets. That is the plan representation will be there. Then what I have to do? I have to take the perpendicular distance of this from the XY line. So I have to measure the perpendicular distance of this point of intersection from the horizontal line. So this point will be called as H dash. Why? Because this appears on vertical plane. All points which appear on vertical plane will be having the notation H dash. So the distance H dash and H will give me my horizontal trace. So since the distance of the line from vertical plane is 25 millimeters, so my horizontal trace will be 25 mm. And next thing, does this plane have any vertical trace? Answer is no. Why no? Because this line happens to be parallel to the vertical plane. So since this line happens to be parallel to the vertical plane, it is not going to intersect with the vertical plane. So it won't have any vertical trace. So I want to now rotate this line in order to draw the projections onto my drawing sheet. So this line will have only HT but no VT. Now I have drawn view above. XY line will be the vertical plane where I am going to draw my front view. View below this XY line will be my top view on HP. Now let us draw this first, because I have to draw this. I am forced to draw this first. Why? Because the line was parallel to VP. So in animation also I have drawn this first. Over here also I am going to draw the front view first. So just see 15 mm I leave. This is the distance of the line from the horizontal plane. So the line starts 15 millimeter and C of the line starts 15 millimeter away from the horizontal plane. So this is 15 millimeter I have left. Now I will draw this line CD. C dash will appear here. D dash will appear 50 mm after C in a vertical line. So just see I have done the marking. So this is my front view, which is giving me the true length of the line. So now I want to draw the top view. So top view and front view, they will fall in one vertical line because the line was perpendicular. I have rotated this horizontal plane downwards. So this distance is 25 millimeter. Just see the line happened to be 25 millimeter in front of VP. Anything in front of VP will be going down. So front of VP goes down XY line, below the XY line. So I have marked point D and C over here. Now I have to work out the horizontal trace. And please check, while we were looking at the animation, point H was drawn first and H dash was drawn second. But when we draw the projections, we have to extend this line. We have to extend this line. When we extend this line, H dash will appear for you. See, we have this projection. I am going to extend this line. So H dash will appear when we draw the projection. So it is just the other way around. So this is the projection in the front view. I am going, does this projection meet my XY line? No. So this projection does not meet my XY line. So since this projection does not meet my XY line, I am going to extend this projection till it meets the XY line. It is just analogous to this situation. I am extending this line till it meets the XY line. So check, I have extended this till I obtain this point. And from this point, what I do? I draw the vertical perpendicular till this perpendicular meets my plan projections. Till this perpendicular meets my plan projections over there. So just see, I am going to draw, this is the extension and this is the perpendicular. So I draw the perpendicular from H dash onto my plan view. So the point which I obtain will be called H. It is this point H. So this point H I have obtained here. And this distance now I am going to call that this distance is my horizontal trace. So my horizontal trace will be equal to 25 millimeter. So this is how you see we draw the projections of a line which are perpendicular to HP and parallel to the vertical planes. Now we pick up the case number 3, projections of the line which is perpendicular to vertical plane and parallel to the horizontal plane. So let us read out the statement. The line EF, it is 50 mm long. Once again, it is perpendicular to the vertical plane. And what are the coordinate locations of the first point of the line? The end E happens to be 20 millimeter above HP and 15 millimeter in front of VP. So you see we have drawn the line over here, and how it is to be spatially located. 20 millimeter, you see this distance will be 20 millimeter. Distance above the horizontal plane will be 20 millimeter, this distance, and distance from the vertical plane is 15 millimeter. So first of all we will have to mark these two distances. Distance from vertical plane we have to mark as 15 millimeter. Distance from the horizontal plane we have to mark as 20 millimeter. So once we mark these two distances, we can draw the length of the line as 50 millimeter. And how do we denote it in the space? Capital E and capital F. Now we have been successfully able to locate this line in the coordinate system, and this line again lies in the quadrant number 1. Now which view we are going to draw? First of all, we are going to draw the top view. Why do we need to draw the top view? Because this line happens to be parallel, because we have underlined the word parallel in the first slide as well. So wherever parallel word will be there, that projection we are going to draw. The projection on that particular plane we are going to draw. So since this line happens to be parallel to the horizontal plane, we are going to draw the projection on HP, that is the top view first of all. So let's see how we can draw it. Observer is going to look from the top. Once the observer is looking at this line from the top, and E will converge on HP, it will project on HP at this position. The name of this point will be small e, and F will be converging on the horizontal plane. It will be projecting on the horizontal plane at this particular point, which will be called small f. So small e and small f, they will give us the top view projections of this particular line, and then you need to join it dark using the HB pencil. So we have been able to obtain the top view projections, and since this line happened to be parallel to horizontal plane, the top view projections which are obtained on HP will reveal the true length of a line. Now we want to draw the front view projections. Now observer is looking at this line from the front side. Again, since this line is perpendicular to VP, the projections of point F and point E, they will coincide as they converge on or as they project upon vertical plane. So they will be converging at a single point. So this point is called F dash and E dash. Why we have put down F dash first? Because observer will be able to look at F first, and then E projections will be superseded by projections of F. They will be overlapped by projections of F. So we have to write down projections of this line F dash and E dash. And since the projections of both the points E and F, they converge, so we call that the front view, which is F dash, E dash. It is giving us the point view of the line. It appears as a point view. Let us now work out the traces of the line. Since this line happens to be perpendicular to the vertical plane, it is going to give us or provide us with the vertical trace. Does this line itself intersect with the vertical plane? Answer is no. This line does not directly intersect with the vertical plane. So what we are required to do, we have to extend this line so as to make it intersect with the vertical plane. So we have to obtain this point of intersection of the line itself or its extension with the vertical plane. So this point's name will be now V dash. Why V dash? Because this point appears on the vertical plane, and all the points which appear on the vertical plane are designated by dash. So this is small v and dash. Now what I have to do to get the vertical trace? I have to take the perpendicular distance of this point from the XY reference line. So this is my XY reference line. I have to drop a perpendicular onto the XY reference line to obtain the perpendicular distance of this point of intersection from the XY line. So I get this point V. Now why this point is named as V? Because it appears on HP. On HP, whatever points they are located, they are designated by small alphabets without any dash. So this distance is my vertical trace. And how much will be this distance? This distance equal to 20 millimeter over here. And does this line has any horizontal trace? Answer is no, because this line happens to be parallel to the HP. So any line which is parallel to HP won't intersect with the HP in any case. So since this line does not intersect with the horizontal plane, it won't have the horizontal trace. Now since this projection and this projection, that is front view projections and top view projections that we have obtained, this one front view and this one is top view. These projections, they are obtained in mutually perpendicular planes. We need to carry out the rotation of this horizontal plane clockwise downwards to be able to draw both of these projections on the same plane, 2D plane. So please see, just like this, I have to draw the projections of the top view on the HP first of all. Why? Because this line used to be parallel to HP. So leave 15 millimeter from vertical plane, it will come down. Length of the line is 50 millimeter. So this E point and F points, they will appear here. I have done the marking, and then I'll write down this is the top view of the line, and it is representing the true length of the line. Now if when I want to draw the front view, so I have to leave 20 millimeter from the horizontal plane. So this distance is 20 millimeter, and E and F, they will both converge at a point over here. So F dash, E dash, as we had mentioned over here. And what is this? This is my front view, which is nothing but point view of the line. So this completes the discussion about third case. Now the vertical trace, now we want to work out. Now it is just the reverse of this. First we identified point V dash, then we identified point V. But in projections, I have to carry out the extension of this line. So whatever the projections I have obtained in the top view, I am going to extend these projections over here. So till it meets the XY line. So first point V will be located, then V dash will be located. So just see, these are the projections of the line as they are obtained on the horizontal plane. I will be extending these projections till this projection line meets my XY line. Once it meets the XY line, then what I'll do, I'll draw the perpendicular distance from this point of intersection to the projections which are obtained on the front view. So just see, from this I will draw a perpendicular from this point to the front view projection. So front view projection is my point. So perpendicular from this V to V dash will give me my vertical trace. And as I told you, vertical trace is equal to 20 millimeter over here. So this is the vertical trace representation onto the projection planes. Now next one, projections of the line inclined to HP and parallel to VP. Now here you have got a line which is 40 millimeter long, and this line happens to be inclined to horizontal plane at an angle of 40 degree. Now in order to be able to locate this spatially into the coordinate system, 3D system, I need to know the coordinates of one of the points of this particular line. So the coordinates of point L, they have been provided to me, that is, and L happens to be 25 millimeter above HP. Just see, 25 millimeter above HP and 10 millimeter in front of VP. So it is 10 millimeter in front, 25 millimeter above. So I have to locate this line. Just see, so location is like this. The line happens to be 10 millimeter in front of VP and 25 millimeter above the horizontal plane. So once I locate this line, point L, then I can draw the line which is at an angle of 40 degree. And we have already discussed that whenever a true length of a line is inclined to the horizontal plane at any given angle, that angle is given the name theta. So the representation or notation of that, the true length inclination with horizontal plane, is called theta. So at an angle of 40 degree, I have drawn 40 mm long line. So LM line has been located in the space, and now which projections I am going to draw? First of all, since this line happens to be parallel to VP, just see, line is parallel, because parallel word is very important. So we have to work out the parallel condition of the line with respect to any plane. So since this line happens to be parallel to VP, so obviously front view we are going to draw first of all. The observer is looking at this line from the front. L point will be converging or projecting on VP over here. Point M will be
projecting on the vertical plane at this point. This point's name is M dash, this point's name is L dash. And since this line is parallel to VP, the projections which are obtained on VP, that is L dash, M dash, will reveal the true length of a line. That is, the front view of the line will reveal its true length. Now let's look at this line from the top. So this is my line. I'm going to look at this line from the top. So since this line is inclined to the horizontal plane, so this we already know by now, if a line is inclined to a reference plane, its projection on that particular reference plane will reveal its shortened view. The line will become foreshortened or reduced. So please check, as I am looking from the top at this particular line, point L of the line will be getting projected on this point on HP. This point is called small l, and the point M, it will get projected on horizontal plane at small m point. And you can see the length of this line is bigger, true length, and length of this line is smaller. That is why we call this line as apparent length. Apparent length is the view, whatever is apparent to the observer, whatever is available to the observer. So since this line happens to be inclined to HP, its view on HP will reveal the shortened view or the reduced view, which is called the apparent length of a line. Now once we draw this, we now draw the connections of L dash and M dash and M, L dash and L, and M dash and M, just to show that the projections of point L and L dash, they will be in one line. Projections of point M dash and M, they will be falling in one vertical line. Now let us work out the traces of the line. Now in order to obtain the traces, first thing is, since this line happens to be parallel to VP, so this line will not have any vertical trace. This is not going to intersect with the vertical plane, so no vertical trace will be there. This line is inclined to HP, so obviously it is going to intersect with HP. Now the question arises, does this line intersect with HP itself? No. Now what we have to do, we have to extend this line. You see, I am going to extend this line. Once I extend this line, I obtain this point as small h. I obtain this point as small h. This is the point of intersection of the line itself or its extension with the horizontal plane. Now how do I obtain the horizontal trace? I have to draw the perpendicular of this onto my XY reference line. So what I'll be doing, I'll be extending this projection also. I'll be extending this projection of the front view, and then wherever this perpendicular distance is meeting this XY line, I will get this notation as H dash. So this distance is going to give me my horizontal trace. And what is the value of my horizontal trace? Since this line happened to be 10 millimeter in front of VP, so it will be intersecting my horizontal plane 10 millimeter ahead of the VP. So this will give me my horizontal trace. Now you can see that the front view I have obtained on vertical plane over here, top view I have obtained on horizontal plane over here. Now but both of these projections, they have been obtained in mutually perpendicular plane. So I have to carry out the rotation of HP clockwise in the downward direction in order to obtain both of these projections on the 2D scale. Now which projection which I will be drawing here? Number one, front view. Why? Because the line happened to be parallel to the vertical plane. So since the line was parallel to vertical plane, so the first projection will be the front view. So the distance from HP of this line is how much? 25 millimeter. Just see, distance of this line from HP, it is 25 millimeter. So leave 25 millimeter. Then draw an angle of 45 degree and draw 40 degree and draw the length of the line as 40 millimeter over here. So I am able to obtain L dash M dash projection, that is front view, which is going to give me the true length at an angle of 40 degree over here. So 40 degree angle is here. I did not show 40 degree again because that would have led to the duplication of the dimensions onto the spatial view. But over here I have to show the 40 degree angle of inclination, and this is the theta angle. Why? Because L dash M dash represents the true length of the line. Now I have to draw the top view. L dash and L projections, they will fall in one vertical line. M dash and M projections, they will be falling in one vertical line. Now I have to leave this 10 millimeter. So leave this distance as 10 millimeter and draw the top view of the line. So this is my top view of the line. So L and M points, they give me the top view of the line. And since I can very well check that LM is shorter than the L dash M dash, so this is the apparent length, and lesser the angle, lesser will be the reduction. More is the angle theta, more will be the reduction, which will be observed over here. Now I want to draw the traces. Now trace, I have, for drawing the trace, I have to extend this L dash M dash projection line. Projection line of the front view has to be extended. Just see, it is reverse. In the spatial view, I was obtaining H first and H dash second. Over here, I am going to extend L dash M dash line because I don't have this capital LM now. I have only L dash M dash which is available to me. So whatever is available, I'll extend that. You see, I am going to extend this. I'll obtain H dash. From H dash, I will draw perpendicular till it meets my plan view itself or its extension over here. Again, I repeat, I will extend my front view projection till it meets the XY line. It gives me H dash. From H dash, I'll draw the perpendicular till this extended perpendicular meets my plan projection itself or its extension over here. So just see, I am going to draw the perpendicular from H dash till this extended perpendicular meets my projection line itself or its extension over there. So this distance I am going to call as horizontal trace. And how much is the value of horizontal trace? This is once again equal to 10 millimeter. So this is case number 4. Now let's pick up case number 5. The line which is inclined to the vertical plane and parallel to the horizontal plane. So the statement reads as a line PQ is 40 mm long. It is parallel to HP and inclined to VP at an angle of 60 degree. So here we'll see that angle of inclination is higher. The reduction in the projections will be more on the vertical plane. Now how to locate this line in the space? I need to get coordinate locations of one of the points, either P or Q. So the coordinate locations of point P have been provided to me. So end P happens to be 25 mm above HP and 10 mm in front. So just see, 25 mm above HP and 10 mm in front of VP, I have to locate point P. So just see, now let us try to locate this point P. Now please check, we have been able to locate point P as shown over here. Point P has been located 25 millimeter above HP. Just see, 25 millimeter above HP and 10 millimeter in front of VP. And then line PQ will be located once I draw this angle phi equal to 60 degree. So this angle is phi. Why did we write angle phi over here? Because this is the angle of the true length of the line with respect to the vertical plane. So any inclination of the line with respect to vertical plane will be shown as phi if the line is true length over here. Now, which view we are going to draw first in this case? We are going to draw the top view in this case because this line happens to be parallel to the horizontal plane. So view on horizontal plane we are required to draw first. And which is the view on horizontal plane? It is the top view of the line. So let's see, observer is looking at this line from the top. Point P will be projected over here on HP as small p. Point Q will be projected on the horizontal plane at this point. This point's name will be Q, and once you join this P with Q, you get the top view of the line. And since this line happened to be parallel to HP, the projection PQ which has been obtained on HP reveals the true length of the line. Now let's look at this line from the front. Now this line is inclined to the vertical plane, so the projections on the vertical plane will be shortened one. So as the observer is looking from front side, this point capital P will be projected on vertical plane over here. This point's name will be small p dash. Similarly, point Q will be projected on the vertical plane over here. This point's name will be small q dash. And we can very well see that true length of the line is much longer than the observed line, that is the front view, which is obtained p dash q dash. Why? Because this angle of inclination is higher in this particular case. And since this p dash q dash, that is the front view obtained on VP, is smaller, we call it as an apparent length. Now we have shown the correlations between p dash and p by joining these lines. Similarly, correlation between q dash and q has been shown, just indicating that p dash will appear just vertically above the p and q dash point will appear vertically above the point q. So let us draw the traces. Which trace this line will have? Since this line is inclined to VP, so this line is going to intersect with the vertical plane. So vertical trace is one trace which this line is going to have. So extend the line PQ capital. It will meet the vertical plane. Wherever it meets the vertical plane, the name of the point of the intersection of the line or its extension with VP will be V dash, because it appears on vertical plane. Then draw the perpendicular till it meets the XY line. So once it meets the XY line, we get the point P. And then you draw this projector line till it meets the extension of the projections which have been obtained in the plan. So first V dash is obtained, then V in the spatial view. Whereas while we draw the projections, first we are going to draw V and then V dash. And what is the value of VT over here? The value of VT will be 25 millimeter, because the distance above HP is 25 millimeter over here. And does this line have any horizontal trace? Answer is no. Why? Because this line happens to be parallel to the horizontal plane. So no way this is going to intersect with the horizontal plane. Now let's draw the projections. So projections front view at P dash Q dash and projections top view, that is PQ, they have been obtained in mutually perpendicular planes. So we have to carry out the rotation of HP clockwise downward so that we can obtain both these projections in the same plane. So which projections we are going to draw first? Top view. Why? Because the line happened to be parallel to the horizontal plane. So distance of this point P from VP was 10 millimeter. So leave 10 millimeter over here. Draw an angle of 60 degree and mark the length of the line as 40 mm. And this is the true length of the line or the top view of the line. This length is equal to 40 millimeter. This is 60 degree. This length is equal to 40 millimeter. We have mentioned true length over here. Then in order to draw the front view lies 25 millimeter. You can see distance of this line above horizontal plane is 25. So we have left 25 millimeter over here. Draw the construction lines, and then P will give us P dash and this Q will give us Q dash. And this is the front view, which is the apparent length. You can see that true length PQ of the line is much bigger than front view, that is the apparent length of the line, which is represented by P dash Q dash. Now let us draw the traces. In order to draw the trace, extend the projection line which was obtained in the top view. Once you extend this till it meets my XY line, so this point gives me V. I will obtain V first of all, and then draw perpendicular vertically upwards till it meets the front view projection line itself or its projection over there. So just see, from V I am going to draw perpendicular upwards till this line, this extended line, meets the front view projection itself or its projection. So wherever it meets its projection, I get this point V. So this distance which I am going to obtain over here will be VT, and VT is equal to 25 millimeter. And this line will not have any horizontal trace because it is parallel to HP. It is not going to intersect with HP. Now the next case number 6, it is regarding the line which is parallel to or contained by the profile plane. So we have picked up a case where the line is contained by the profile plane. So this is my horizontal plane, this is my vertical plane, and I have drawn a profile plane over here. Now how do I locate the coordinates of my points R and S over here? They have been provided in the statement. So let us read out the statement. A line RS is located in first quadrant and it is parallel to the profile plane. It is inclined to both HP and VP, and since this line happens to be inclined to both HP and VP, so on HP and on VP we are not going to get the true lengths of the line. View obtained on HP will be apparent length, view obtained on VP will also be the apparent length of the line. Now let us first of all locate the lines spatially in the space. So this line is to be located in the profile plane, just see, and R of the line is located 20 millimeter above HP, just see, 20 millimeter above HP. I have drawn a construction line, and 25 millimeter in front of VP, just see, 25 millimeter. So by the intersection of these two lines I am able to get location of this point R in the profile plane. And mind you, how the point R will be denoted? R double dash, because it is located in profile plane. So any point which is located in the profile plane will be denoted by R double dash. Let us work out the coordinates of point S. And S is 60 mm above HP, just see, 60 mm above HP. This is 60 mm above HP. I have drawn a line, and 40 millimeter in front of VP. So 40 millimeter in front, 60 millimeter above HP, S point has been located. R was located here, 20 millimeter above HP and 25 millimeter in front of VP. Let us join these 2 points, R double dash and S double dash. So this is the true length of a line. This is the true length of a line. Why? Because this happens to be lying in the profile plane, or it is parallel to the profile plane. Now, having obtained the true length, I need to draw the projections in the front view as well as in the top view. So just see, I want to look from the front. As the observer looks from the front, these points R double dash and S double dash will project on this particular position. This point will be R dash, this point will be S dash. So if you want to draw it over here, it is already a very dark line. So I am showing it over here so that I can show you the unique points over here. But while I draw it onto the projections, I will be showing it onto this particular line itself. So you could have drawn this R dash over here, S dash over here. I have drawn it over here, assuming that I want to show you these projections uniquely other than the ones which are drawn on the x1 y1 line over here. This is my apparent length because this is the reduced length. Why? Because my line R double dash S double dash happens to be inclined to the vertical plane. So this is true length, this is the shortened length. So R dash S dash gives me the shortened length of the line. Now let's look at this line from the top. So the projections obtained will be over here, R and S. But once again, I wanted to show you these projections unique. So I have extended this over here. Point R will be located here, point S. Otherwise, you could have shown it over here. R could have been located here, S could have been located here. Now, once you locate R dash, S dash, R and S over here, now I need to rotate this horizontal plane over here and vertical plane like this so that I can show front view, top view and side view on the same plane. So let us do that. So this is my profile plane, please check. This is my vertical plane, this is my horizontal plane. So let us locate point R on the profile plane, just check. 20 mm above HP, 25 mm in front of VP. 20 mm above HP means 2 blocks we have left. 25 mm in front of VP, 2.5 blocks we have left. Then S point is 60 mm above HP, 6 blocks, 1, 2, 3, 4, 5, 6, 40 mm in front of VP. So this is 40 mm in front. So S has also been located. Join this. This is my true length of the line. So R double dash, S double dash represents the true length. Now I am going to look at this line from the front. As I look at this from the front, projections I am going to draw over here. So I have drawn a larger thickness line. Again, I have changed the color also. R dash and S dash. And this is, since the line is inclined to VP, this projection gives me my apparent length. So front view gives my apparent length, that is R dash S dash. Look at this from the top. R will appear here, S will appear here. And now these two are there in mutually perpendicular planes. Rotation will be required. So I rotate this R over here, rotate this S over here. After rotation, I get the projections of the line in the top view. And once again, it is a shortened length. And now you can check, top view is much shorter than the front view. Reason, angle with VP is lesser and angle with the horizontal plane is higher. Now coming to the last case, that is line which is contained by both the reference plane. So this is similar to the case 1, but the only difference is that is the distance of the line from HP is 0, distance from the line from the VP is 0. So I can locate this line directly on the XY line. So this is the spatial location of the line in the coordinate plane HP and VP. Now once you look at this line from the front, the projections of the line and the original line, they will overlap. So A dash, B dash will be once again true length, and this will be overlapping with the capital A and capital B. So projection of the front view will appear on the XY line because the line lies on HP. Similarly, while you look at this line from the top, so once again projections of this line capital A, capital B will again lie on XY line because line is contained by the vertical plane. So the top view is also going to overlap with the original line and the front view projection. And the name of these projections will be once again small a, small b. And once again this will be true length. So original line, front view and top view, all three will be true lengths. And then we need to rotate this horizontal plane. And since this line is contained by HP, VP, so it won't have any of the traces. So let's draw the projections. So I've drawn the planes over here, vertical plane, horizontal plane and XY line. Now front view I have taken as blue, which is true length, A dash, B dash, 40 mm long. Top view, once again this will overlap. Just see, this is going to overlap and it will be represented by small ab, and again it represents the true length. So this is all about the 7 cases of the projections of the lines that we wanted to discuss today. So I hope that this spatial illustration as well as the 2D representations would have helped you to develop better understanding of the projections of the lines. So we'll continue with the special cases of projections of line in our next lecture discussion. So thank you very much. Thanks a lot.